Hey there, I'm Shivaji and you are learning data structures with me in this course. Okay, in this tutorial, I'm going to dry run the algorithms that we developed in the last tutorial in order to implement the double-ended queue. So we need to initialize the front at 0 and rear at -1. You can see that the front is here at 0 right now and rear is at -1. And we'll be actually doing the operations one after another and we'll see how that works. So let us first call this insert at rear and I'll be passing 5 there. We have taken the size of the array as 5. You can see that there are 5 elements in this array. Okay, we're calling this insert at rear at very beginning and passing on 5 there in order to insert at the rear end. So first of all, rear is -1 and size -1 is 4. So that is not true. So we can insert at the rear end. So what will happen? Rear will be incremented by 1. Rear goes here at 0. So rear is right now 0. Earlier it was -1. Now we'll be placing the value v at the rear index of the item according to the line number 13. So item rear is v. So we are placing 5 here. So that is inserted at the rear end. Now if you want to insert one more element at the rear end, say we want to insert 10 at the rear end, then we'll be moving up the rear once more. So rear will be moved up to index 1 from 0 according to this statement at line number 12. So rear is rear plus 1. So rear is currently 0. So it goes to 1. And then we'll be placing the value v at the rear index of the item. So 10 is placed here. Now if I want to do the same thing again, that means I want to call the insert at rear once more with the value 15. Then again you see that rear is right now 1 and size -1 is 4. So we can add a new element at the rear end. So rear will be again moved up by 1. So currently rear is at 1. So rear will be at 2 after this operation at line 12. Then we'll be placing the value 15 there at the rear index. So 15 is placed here. Now let us try calling the insertion at the front at this point of time. So we have this situation right now and I'd like to call the insertion at the front. Now if I call the insertion at the front now, it will actually fail. Front is right now at 0, you see. So we cannot insert at front. This condition is going to be true because the front is right now at 0 and it will print unable to insert at front and it will exit from this operation. So let us now try to delete from the front by calling this delete from front function. Okay, if we call that delete from front, then what will happen? First of all, it will check if the array is empty or not. Is the front greater than rear? No, it is not, because the front is 0 and rear is 2. So this fails. That means the array is not empty, so we can delete from front. So obviously we'll be actually getting the value, we'll be picking up the value from the front. So we can pick up the value from the front. So at line 39, as you can see, we are getting the value from the front there and we are assigning that value here at v, and then we'll be moving the front up by 1 element. So currently the front is at 0. It will be added with 1, so the front goes to 1, and then obviously we'll be returning the value from there. I need to add one more statement there in the algorithm. So the function is going to return 5 and that is deleted from the front, and the front moves up as you can see. Now if we try to delete from the rear end, then we can call that delete del underscore from underscore rear and we can see how that works. So let us now call this del from rear. And front is greater than rear? No, it is not, because front is 1 and rear is 2. So we can just pick up the value from the rear end. As you can see, item rear, that is 15, will be assigned here at v. And then we are going to decrement the rear by 1. So rear is right now 2. It will be 1 after this operation. So both rear and front are right now 1. And now we are returning v. That means 15 will be returned to the caller. So 15 gets deleted from the rear end. Now if we want to insert at the front end of this double-ended queue, then we can do that. Let's now perform the insertion at front. As you can see, at the very beginning, it will test if the front is there at index 0 or not. It is not at index 0, it is at index 1. So obviously we can perform the insertion at the front operation. So now front will be decremented by 1. So front comes here at 0. And then we can place the value at the front index of the item array. Say the value that we want to insert is 8. So we are inserting 8 here at the 0th index. That means at the front. So that's how the insertion at the front actually takes place there according to the algorithm. Now, if you want to delete from the front, then what you'll be doing, you'll be actually deleting this 8 and you'll be increasing the front by 1. Now, if you want to perform delete from front, then what you'll be doing, you will be actually checking the underflow again. So here you can see front is greater than rear. No, it is not, because front is 0 and rear is 1. Then it comes here, it picks up the value from the front, and that is 8. So 8 will be picked up and assigned there at V, and then the front will be moved up by 1. So the front comes at 1, and the value V is returned. So 8 is returned to the caller. Now, if we want to perform the delete at front once more, then it's okay, we can do that. You can see front greater than rear this time is false because the front is 1 and the rear is 1. So greater than fails, and we come here again and we pick up the value from the front, that is 10. And then front is moved up by 1. So front goes at index 2. And we return this 10 to the caller. Now, if you call this del underscore from underscore front again one more time, then it's going to show that the queue is underflow, because at this time front is 2 and the rear is 1, and this satisfies, right? And it will say that the queue is underflow. And if you want to delete from the rear as well, the underflow condition will be satisfied and it will say that the queue is underflow. So again, you can just go ahead and insert some more elements at either end and can see how that works. So this is actually perfect now, and we can go ahead and write the program for this. I will recommend you to just write and with some more NQ and DQ operations on either end and see if you are comfortable with this. Thank you very much.